So, good morning, students. Am I audible to you? Good morning. Am I audible to you? Good morning, students. Am I audible to you? You have to give the reply. Good morning.
Good morning,
Good morning,
sir.
sir.
Okay, I am audible to you, na?
Good morning, sir.
Okay. So today I'll start inverse of a matrix. Okay. So in the last class, you were able to know some defined kind of matrix. Wait. Okay, let's start. So at first you have to know what is inverse of a matrix. Clear? So what is given? See here, let if A and B are two square matrices of same order such that AB equal to BA equal to I. Here I means identity matrix. Okay. So here I means identity matrix. Then B is called the inverse of A. That means B equal to A inverse. At the same time, A is also called the inverse of B. That means if you got AB equal to BA equal to I, then what happened? Both A is inverse of B and B is inverse of A. Clear? Now see here. Now next thing is how we can find the inverse of a matrix. How we can find out the inverse of a matrix. So there is two way. So in your HS you got how you can find out the inverse of a matrix by using adjoint of a matrix. Clear? So some people are still waiting. Okay, see here. So inverse of a matrix, there is one formula, A inverse equal to 1 by determinant of A into adjoint of A. Now, if this determinant of A equal to 0, then A inverse does not exist. Okay, if this one equal to 0, then A inverse does not exist. Clear? So for that, determinant of A must not equal to 0. So see here, this is a matrix. We have to find out A inverse. So for that, see here, at first you have to find out determinant of A. I have to admit to, I already given admit to all. Then why some of you are not able to enter the class?
Full size দেখে যা মই নেজানো মই ৰিপ্লাই বেক নিবিচাৰো নিনি যিমানটো পোৱা যায় সিমানটো কৰিবি
Okay, now see.
Hello, excuse me, sir. Hello.
Now, okay, see
Excuse
here.
me, sir.
Yeah.
Sir, there are students waiting outside the room.
Yeah, and I
trying
admit
to get
all
in.
of this. I
Okay,
admit
okay.
all the students, but why they are waiting? Okay, now see. At first, you have to find out A inverse. Okay, so to find out A inverse, at first you have to find out determinant of A. So I think all of you know how you can find out determinant of a matrix. Okay, so if you expand along first row, then what happens? 3 into minus 3 minus minus 4. So minus minus it will becomes plus 4. Again, this is minus of minus 3. So that's why it is plus 2 into 1. This is 2 minus 4 into 0. It will be 0. Plus 4 into 2 into minus 1. It is minus 2. Minus 0 into minus 3. So it will be 0. So you got determinant of A is equal to what? 1, which is not equal to 0. Okay, which is not equal to 0. Clear? So at first we find out determinant of A, which is not equal to 0. So that's why A inverse exists. I already admit the students so many times, but why they were still waiting? Okay. So now see, at first we have to find out the cofactor along first row. Cofactor along first row. See the matrix. Is there any other way to admit all these students? Do you know anyone? Initially, I already admit all of the students, admit to all. So why the students are waiting? Is there any other way, anyone? Okay. See here, now we have to find out the cofactor along first row. Okay, cofactor along first row. See here, what is cofactor of 3? Cofactor of 3. See, you have to cofactor of 3. This 3 is what? You have to exclude this entire row and exclude this entire column. Okay, to find out the cofactor of 3, you have to exclude this entire row and this entire column. Now you will get a second order determinant, which is minus 3, 4, minus 1, 1. Okay, so now if you find out the determinant of this, then what you got? Minus 3 into 1, minus 3, minus 1 into 4. So it will be plus 4. So minus 3 plus 4, it will be what? Equal to 1. Okay, so similar way, what is cofactor of minus 3? See here, what is cofactor of minus 3? You have to exclude this entire row, that means first row, and this entire second column. Now what is left? 2, 4, 0, minus 0, 1. Okay, so you have to find out this determinant of 2, 4, 0, 1. So 2 ones are 2, minus 0 into 4, 0. So it will be 2. Okay, it will be, see here. So 1 minus sign is come due to it, since it is first row second element. Clear? So I think you know all of this, how you can find out the cofactor of an element. Clear? So cofactor of minus 3 is minus 2. Cofactor of 4 is also minus 2. See here, cofactor of 4. So for to find out cofactor of 4, you have to exclude this entire row and this entire column. Okay, exclude this first row and third column. What do you get? You got 2, minus 3, and 0 and 1. 2, minus 3, 0, 1. Clear? So if you expand this one, then what you got? If you expand this one, what you got? 2, 1, 2 minus 1, minus 2, minus 0. So it will be minus 2. Clear? Now we are going to find out cofactor along second row. Okay, cofactor along second row. So first one is what? Cofactor of 2. See here, you have to listen carefully to know how you can find out the cofactor. So cofactor of 2. So this element lies in which row? Second row. And in which column? First column. So that's why you have to exclude this entire second row and this entire first column. Okay, entire second row and entire first column. What is left? Minus 3, 4. Keep silent, someone noisy. So minus 3, 4 minus 1 1. So if you expand this, what you got? Minus 3 into 1 minus 3 minus 1 into 4. So it will be plus 4. Minus 3 plus 4. Okay. Someone keep noisy, keep silent.
Excuse me, sir.
Yeah.
Sir, said that mute the mic, sir.
What happened?
Sir, say them to mute their mic, sir.
Okay, mute. All of you mute your mics. Keep silent. Who is this? Keep silent.
This is Salim Masood Mutadi.
So how I can mute this? Okay, I do it. Okay, see here. So cofactor along second row. See here. Okay, these two. Okay, so 2. See, this 2 is lies in which row? Second row. And in which column? First column. So you have to exclude this entire second row and this first column. Now what is left only? Minus 3, 4, minus 1, 1. Okay. So you have to find out this you have to expand this determinant. So what you got? Minus 3 into 1. Minus 3 minus 1 into 4, so plus 4. Okay, so you got from here you got 1, but there will be one minus will come. Okay, see here, so it will be minus 1. This is comes from, see here, along the property of cofactor. So in this way we can find out the cofactor of any elements of a matrix. Okay, in this way we can find out the cofactor of any elements of a matrix. So after that, what we have to do, after find out the cofactor of the elements along all these 3 rows, we will get adjoint of A. See here how we can directly find out adjoint of A. You have to put the cofactor of first row, cofactor along first row, 1 minus 2 minus 2. You have to put it in the first column. Okay, you have to put it in the first column, 1 minus 2 minus 2. Now what is cofactor of second row? This is minus 1, 3, 3. So you have to put in second, you have to put it second column, minus 1, 3, 3. Now cofactor along third row is 0, minus 4, minus 3. Okay, 0, minus 4, minus 3. You have to put it in the third column, 0, minus 4, minus 3. So, okay, listen. So how we can find out adjoint of A? At first, you have to find out the cofactor of the elements along all these 3 rows. Okay. After that, simply you have to put the elements of first row in the first column. Again, put the cofactor of second row in the second column. Again, put the cofactor of third row in the third column. So this is your adjoint of A. Clear? So after finding the adjoint of a matrix, excuse me, you have to find, you will get A inverse. Okay. So what is A inverse? It is 1 by determinant of A into adjoint of A. So determinant of A we already got. So it is 1. Now this is adjoint of this one. Okay. So this is the inverse of A. Clear? Now listen, if you multiply the matrix A with this A inverse, then you will get identity matrix. So this is one way how we can find out the inverse of a matrix. That means by using adjoint of the matrix. Clear? Now next one is how we can find out the inverse of a matrix by using elementary transformation. Okay. So here this three property we have to use. Okay, first one is what? Interchanging any two rows or column. So this is a matrix. Here we can interchange any two rows or any two column. See here, we interchange row 1 to row 2 and row 2 to row 1. That means in place of row 1, what is row 1? 1, 2, 3. We are going to put row 2, 4, 5, 6. 4, 5, 6. Again, in place of row 2, we put row 1, 1, 2, 3. Okay, so this is the first property. We can interchange any two row or any two column. Clear? Now, what is the second property? Multiplication of the elements of any row or column by a non-zero scalar quantity. So this is a matrix. Okay, so we multiply the elements of column 3 by 5. Listen, you cannot multiply with 0. Okay, you cannot multiply with 0. You have to multiply by a non-zero numbers. That means non-zero scalar quantity. So here column 3 tends to 5 column 3. That means every elements of column 3 you have to multiply with what? 5. So 5 into minus 1, it will be minus 5. 5 into 1, it will be 5. 5 into 5, it will be 25. Clear? So next one is, third one is what? Addition of constant multiplication of the elements of any rows Rj to the corresponding elements of any other row Rj is denoted by, it should be Ri. Okay, it should be Ri. Any row Ri to the corresponding elements of any other row Rj is denoted by Ri plus Krj. So here is the matrix. Here row 1 is changed to row 1 plus 2 row 2. Row 1 tends to row 1 plus 2 row 2. See here, what is the first element of row 1? Minus 1. Minus 1 plus 2 into 0, it will be minus 1. Next 2 plus 2 into 1, there's some mistake. It will be 4. Okay, it will be 4. 2 plus 2, so it should be 4. Again 5 plus 2 into 2, that means 5 plus 4, it is 9. Okay, now listen to me. Whenever you are going to change any row with the help of some other row, okay, with the help of some other row, then what happen? You cannot multiply that row with some constant. Here see, this row 1 is changing with the help of row 2. So that's why we cannot multiply row 1 with some constant. Okay, here you can multiply with some constant, no problem. But row 1 cannot be multiplied with some constant. Clear, all of you? Next, see, I'll give one example. This one, see here. Find the inverse of this matrix. Find the inverse of the matrix A equal to minus 1, 1 to this one with the help of elementary row transformation. Okay, with the help of elementary row transformation. Okay, now see here. Now A can be written as I into A. Okay, because A is a matrix and I is an identity matrix. So you already know that if you multiply any matrix with the identity matrix, the result is always the same matrix. Clear? So that's why A can be written as I into A. So here we put the matrix A, here we put the matrix A, and this is the identity matrix. This is the identity matrix, and this is the matrix A. Clear? Now see here, now our aim is we have to make this matrix, that means the matrix of the left side, we have to convert this matrix to an identity matrix. We have to convert this matrix to an identity matrix by using those three elementary operations. Clear? So that's why our first aim is always you have to make this element equal to 1. It can be -1 also, no problem. Either you have to make this one to 1 or you have to make this one equal to -1. So after that you have to make those elements equal to 0. Those elements equal to 0. Clear? Now see how you can make these elements equal to 0. You can easily make these elements equal to 0. How? Because -1 plus 1, -1 plus 1, which becomes equal to what? 0. So that's why what we have done, row 2 tends to row 2 plus row 1. Row 2 tends to row 2 plus row 1. So if we add this one, -1 plus 1, we got 0. 2 plus 1, we got 3. Again 3 plus 2, we got 5. Okay, now same operation you have to done here also. So 0 plus 1, it is 1. 1 plus 0, it is 1. 0 plus 0, it is 0. Clear? At the same time, we can make this element equal to 0. So how you can make this one equal to 0? So it is 3 plus -3. Okay, 3 minus -3. So it will become equal to 0. So how we can do this one? Row 3 tends to row 3 plus 3 row 1. Row 3 tends to row 3 plus 3 row 1. So 3 plus 3 into -1. That means 3 minus 3 equal to 0. Next, 1 plus 3 into 1. 1 plus 3, which is equal to 4. Again, 1 plus 3 2s are 6. So 1 plus 6, it will become what? 7. Clear? Same operation you have to done here also. This is 0 plus 3 into 1. So 0 plus 3, it will be 3. Next 0 plus 0, it will be 0. Again 1 plus 0, it will be 1. Okay, so this is our first step. At first you have to make these elements equal to 0. Okay, now see after that, we make these elements. After that we make this element equal to 1. So how we can make this element equal to 1? You have to multiply by -1. Hello, Novoda, class. Okay, so see we have to make these elements equal to 1. How we can make this element equal to 1? You have to multiply by -1. So -1 into 1. So it will 1 -1 -2. Same operation you have to done on the right hand side also. So it is again -1 0 0. Clear? So after that, see here, our aim is anyhow you have to make these two elements either this equal to 1 or this is equal to 0. Clear? Anyhow we have to make these elements either equal to 1 or equal to what? 0. So how we can make this element equal to 1 or -1? See here, if you done this operation, row 2 tends to row 2 minus row 3, then what happens? 0 minus 0, it will be 0. 3 minus 4, it will be -1. 5 minus 7, it will be -2. Okay, same operation you have to done here also. 1 minus 3 minus 2, 1 minus 0, 1 minus 0, it will be 0. The 0 minus 1, it will be -1. Okay, 0 minus 1, it will be -1. Okay, So we make this element equal to -1. Okay. Now see here, our aim is you have to make this matrix to an identity matrix. So now we can make this one equal to 0 and this one equal to 0 by using row 2. We can make this one and this one equal to 0 by using row 2. At the same time, we can make this element also equal to 0 by using this row 2. Clear? So how we can make this? Row 1 tends to row 1 minus row 2. So 1 minus 0, it is 1, minus 1, minus 1. That means -1 plus 1, which is equal to 0. So -2 minus -2. So -2 plus 2, which is equal to 0. Okay, same operation we done here also. -1 minus -2. That means -1 plus 2, which is equal to 1. Again 0 minus 1, so -1. Again 0 minus -1, so it will be +1. Okay, so same here, row 3 tends to row 3 plus 4 row 2. Okay, see here, 4 plus 4 into -1, so it will be 0. Again 7 plus 4 into -2, so it will be -1. Same operation you have to done on the right hand side also. Okay, so you listen one thing, see what happened in this step. To change row 1 and row 3, we use row 2. Okay, to change row 1 and row 3, we use row 2. So at this same step, you cannot change row 2. Listen all of you. Here we change row 1 and row 3 with the help of what? With the help of row 2. So at this same step, you cannot change row 2. Clear? Now see, after you get this one, we multiply row 2 by -1. Okay, so that this element becomes equal to 1. So what you got? 0, 1, 2. Here you also we multiplied by -1. So you got this is 2 minus 1, 1. Clear? 2 minus 1, 1. So next step, what is left only? You have to make this element equal to 0 and this element equal to 1. Very simple. How you can make this equal to 0? 2 minus 2. So how you can do this one? Row 2 tends to row 2 plus 2 row 3. Row 2 tends to row 2 plus 2 row 3. So 2 plus 2 into -1. So 2 minus 2, which is equal to 0. Same operation we done here also. 2 plus 2 into -5. That means 2 minus 10. So which is -8. Same way this we will get. Okay. Now what is left only? This is -1. We can easily make this one equal to 1 by multiplying by -1. So when you multiply by -1, what you got? Row 3 tends to minus row 3. So you got this is equal to 1. Same operation you have to done here also. Okay. Now see, now what you got? Suppose it is the matrix I and it is some matrix B and this is A. Then what you got? BA equal to I. So obviously B can be saying what? B is the inverse of A. So therefore A inverse equal to this one. Okay. Now you tell me, is there any doubt? Yeah, you can ask me if is there any doubt. You can ask me anyone if is there any doubt. Okay then. This is find the inverse of the matrix. So it is a fourth order matrix. Okay. Previous one is a third order matrix. It is a fourth order matrix. So same way we can write a matrix A equal to I into A. We can write a matrix A equal to I into A, where I is the identity matrix. Clear? So this one we write, this is the matrix A and this is the identity matrix I. So our first aim is you have to make this element equal to 1. You have to make this element equal to 1. Now come to the second row. See here, this is already 1. So what we have done, we interchanged row 1 with row 2. We interchange row 1 with row 2. So see here, in place of row 1, we put row 2. 1, 1, minus 1, minus 2. And in place of row 2, we put row 1, 0, 2, 1, 3. Clear? We put row 1, 0, 2, 1, 3. Same operation you have to done here also. So in place of row 1, we put row 2, 0, 1, 0, 0. And in place of row 2, we put row 1, 1, 0, 0, 0. Okay, 1, 0, 0, 0. So next step, see here. So after making this element equal to 1, our next aim is we have to make the corresponding elements of column 1 to equal to 0. Okay, at first, see, always listen. Our first aim is you have to make this element equal to 1. After that, you have to make the corresponding elements of column 1 equal to 0. Okay, so this elements is already 0, so there's no problem. So this one we can easily make equal to 0 by using this one. Okay, so how? 1 minus 1 equal to 0. Similarly, this one also easily make equal to 0. How? Minus 1 plus 1 is equal to 0. So what we have done here, see, row 3 tends to row 3 minus row 1. Row 3 tends to row 3 minus row 1. So this 1 minus 1 equal to 0. 2 minus 1 equal to 1, 0 minus minus 1, which is equal to plus 1, again 1 minus minus 2, which is equal to 1 plus 2, 3. Again, row 4 tends to row 4 plus row 1. So minus 1 plus 1, which is equal to 0, 1 plus 1, which is equal to 2, again 2 minus 1, which is equal to 1, 6 minus 2, which is equal to 4. So same operation you have to done in the right hand side also. Same operation. Now see, now we interchange row 3 with row 2. Because our aim is you have to make this element to make the matrix to an identity matrix. So these diagonal elements must be equal to 1. So that's why we interchange this row 3 with row 2 so that this element becomes equal to 1. So simply we interchange row 3 with row 2. So after interchanging row 3 with row 2, we got this one. Clear? So next step, see here, we can easily make these two elements equal to 0 by row 2. We can easily make this one and this one equal to 0 by using row 2. Clear? So row 3 tends to row 3 minus 2 row 2. So 2 minus 2 into 1. So this is 0. Same, simply we multiply this. Okay. Same, we simply use this operation. Okay. There is nothing. Simply our aim is we have to make the left hand side matrix to an identity matrix. Okay. So that's why we make this element equal to 0. So in the next step, what we have done, row 4 tends to row 4 minus row 3. So that this elements also becomes equal to 0 and this element equal to 1. Okay. So 0 minus 0, 0, 0 minus 0, 0, minus 1, minus minus 1. So minus 1 plus 1, it is 0, minus 2 plus 3, which is equal to 1. Same operation you have to done on the right hand side also. Now what we have done, we multiply row 3 by minus row 3. We multiply row 3, we change row 3 to minus row 3. So you have to multiply the elements of row 3 by minus sign. Okay. So when you multiply by minus sign, it is 1 and 3. Same operation we done on the right hand side also. Now what is left only, you have to make these elements equal to 0. You have to make these elements equal to 0. Now one single step we can make these elements equal to 0. See how? This row 1 tends to row 1 plus 2 row 4. Row 1 tends to row 1 plus 2 row 4, so that these elements becomes equal to 0. See here, minus 2 plus 2 into 2. 2 into 1, so it is equal to 0. Same way, row 2 tends to row 2 minus 3 row 4, so that this element is equal to 0, so that this element equal to 0. 3 minus 3 into 3, 1, so it is 0. Same operation you done here also. Row 3 tends to row 3 minus 3 row 4. Okay. So similarly, by proceeding in this way, I discuss all this step here. At last you will get this identity matrix. Okay, at last you get this identity matrix, and obviously then we can say this is the inverse of A. Okay, this is the inverse of A. Okay, so now that's all for today. Now you ask some question if is there any doubt. Actually it is difficult to discuss such kind of problem here. So you can ask me. Anyone? Alak Sen, is there any doubt? Alak Sen, is there any doubt? CTIS rule number 8.
No, sir.
You got it?
Yes, sir.
Now, if is there any doubt, you can ask me. Actually, I will give the PDF in our WhatsApp group and check yourself, all of you. Obviously, there must be some doubts, obviously. So you can ask me, no problem. Anurag Chaudhary. Any doubt? Yeah, you can ask me. Okay, then no problem. Obviously, there must be some doubts. So I will give the PDF in our WhatsApp group and check yourself. If is there any doubt, you can ask me anytime. Okay, you can give this in our group also, no problem. Okay then, so that's all for today. So give your attendance in the group. Okay then, that's all.